Hello students, welcome to yet another lesson in this series. In this chapter, we will learn about LDR, that is a basic sensor, and also try to make a project out of it.
Before jumping into circuits and the components, let's first understand the concept of analog signal. The analog signal simply means that if you're measuring voltage or any other parameter against time, then the readings are continuous. It can achieve any maximum or minimum value within the allowed limits. If we represent the signal graphically, then the analog signal will be a continuous line where on one axis it has to be time. Some common examples of analog signals is human voice, AM or FM radio signals, and audio signals. Let's dive into build phase, where we will practically see analog signals using one LDR. This is the circuit of our project that we'll use throughout this lesson. You can draw it on paper for your reference, though we'll keep bringing it up whenever needed.
So let's begin the construction of our circuit. But before that, we'll have to understand the breadboard, how the wirings work in this breadboard. So here the top row is internally connected. Both of them are internally connected, means this row, first one on the top, is connected. So it's nothing else but one wire internal inside this breadboard. Same way there is direct connection between all the pins in the second row. But here in the center, the pins which are numbered, like one row number, the column number 1 is internally connected from A to E, and then F and F till J is internally connected, but these two sets are not connected. So this is one connection, one wire, this is another wire, but these two are different wires. Okay, now let's begin the construction of our circuit. But before that, I'll want to show you what all we need. One is the wire of our Uno, of course our Uno board, then a 10K resistance. I have taken one LED, I have taken blue one, then we have LDR and some jumper wires. Okay, I'll bring the circuit board, breadboard in the center. Thereafter, let me place my Uno properly, and we'll start connecting these wires as per the circuit diagram. So here I see that the first one is the red, which is the positive 5 volt connection. So we'll connect this 5 volt. Let me use the red wire. So there's one pin in that goes to 5 volt, and I'll connect it to the positive line on the breadboard. So this will become a positive rail. Then we have our ground pin, it goes to the negative rail of the breadboard. So now we have given the power supply. Thereafter we will place our LDR on this board. You can place it actually anywhere. So placing it on 17 and 16, pin number 16 and 17. Now if you see the circuit, then one leg of the LDR is connected to positive. So I'll connect the pin number 17 to positive rail, and on the negative end of the LDR we have our resistance getting connected. So I'll put the resistance in pin number 16 and other one on the some random number, let's say 10 or 9, whatever, doesn't matter much here. Okay, so this connection is done. Then our breadboard says, our circuit diagram says that the other leg of resistance goes to ground. So I'll pick one jumper wire and connect the other leg of the resistance to the ground pin. Thereafter, the junction at which we have our resistance and the LDR, from that junction I'll take the output reading. So this is pin number 16. Let me bring back the focus of the camera, and it goes to A0. So there you go. Now your circuit diagram is complete. Okay. Let me show you from here. So this is how your circuit should look as well. One last thing that we need to do is add the LED to pin number 13 and the ground. So here our LED has two legs. One is longer one and another one is shorter. So the longer one is the positive end, shorter one is negative. So we'll put the longer one in pin number 13 of Arduino. Let's see. So this is how I will connect pin number 13 and ground. So this way we have connected our LED to the board as well.
Now let's look at the programming part of it. Here I would request you all to write this program on your IDE. So in the first line, we are creating a variable called sensor pin in which we are assigning A0. So if you remember, our LDR is connected to the pin A0. Then we are initializing another variable which is named as sensor value. Here in this, we will temporarily store the value or the readings coming in from our LDR. Next is the setup function. So if you remember, then setup is like the constructor in C++, which is used to initialize all the variables. Here we are initializing serial communication. So this is a class within Arduino programming that is predefined and you need not import anything to activate it. This is a class which has a function called as begin. So serial class actually handles all the data communication happening between the computer and your Arduino board, which is Uno in this case. Then it asks for a parameter which is baud rate. Basically, it is the rate at which the data transmission happens. It is very important. So if your Arduino is sending it at 9600 speed, then your board or the serial monitor should also read it at the same baud rate. Otherwise, you will not see anything on the serial communicator. Then in the loop function, this is the function which will run forever, right? After the setup is complete. So in the loop function, we are reading the value of sensor pin number A0 using the function analog read and storing it in sensor value. Thereafter, Arduino is printing this sensor value using the function called println. So serial class has a function called println, where println means print in a new line, print this value in a unique line. Thereafter, we are waiting for 100 milliseconds. That is basically to give some time to the sensor, and then again the loop repeats itself. So here the expectation would be that we read the value, we print it on a serial monitor, and then repeat this process infinitely. So if you notice, then we are actually reading the values continuously, right? So what we'll do is we'll put a torch or a light source on the LDR, and see what values it is giving to us. So once it becomes, because it is sensing light, so obviously we'll increase the light and we'll decrease the light and see how the readings change based on the light that it receives.
So let's see how the readings change based on the light intensity falling on this LDR. So right now there is enough light falling on the LDR, so you can see numbers somewhere close to 900. And now I have put my hand and a little bit shadow on the LDR, so you see the reading has gone down to 700. I'll in fact keep my hand almost on the LDR, so you see that the numbers have gone further down to 400, 500 kind of a range, right? So based on light falling on the LDR, the readings would change. The more the light, the higher the numbers, and the lesser the light and lower the numbers. So you can figure out whether it is dark or bright outside based on the light falling on the LDR.
Next, I have a challenge for you. You have to switch on the LED on pin number 13 whenever it is dark and switch it off whenever it is bright and the light is falling on the LDR. Pause this video and try this program. I hope you were able to write the program. If not, then just simply follow this one. In this, I have added pin mode to built-in LED, which is pin number 13 as output in the setup function. Then I have added a if else block. Wherever sensor values goes below 500, it means for me it is dark, and the light will turn on by writing digital high onto built-in LED, and otherwise it will turn off. So let's see how it works after uploading the program on Arduino.
Now let's see this in action. When I keep my hand on the LDR, yeah, there you go. The light switches on, and when I remove my hand and the light is falling on the LDR, then the light switches off. So you have made a automatic light here. Now for you the values threshold value might be different. For me it was 500, but for you it might be different because that number is based on the environment lighting that this LDR is receiving. So you may have to adjust to make it work.
This brings us to the end of current lesson. I hope you enjoyed making this project. In the next one, we'll learn about digital signals. So, see you there.